Hey guys, so this video covers questions related to the topic of indices, okay? It's important to learn the theory, but honestly, you can't really understand the theory properly if you don't know questions or how to do questions on them, right? So that's why I do these videos on questions. Again, if you didn't watch the video on indices theory before, I highly recommend you watch that before because a lot of the concepts discussed in that video are going to be on this video. Okay, so let's get right into it. Okay, so we have x plus 4 root x minus 32 is equal to 0. Okay, and we want to find the value of x's for which this function exists. Now, this is a really common question, and what we call this is a deceptive quadratic. Okay, this is really a quadratic here, right? But we say it's a deceptive quadratic because you have to convert it into quadratic form. Okay, so this here again is what we call a deceptive quadratic. Okay, so we have root x. Okay, remember x is actually root x all squared. Okay, plus 4 root x minus 32 is equal to 0. Okay, so what we're going to do here now is, because it'd be really complicated to factorize root x, we're going to replace root x. So what we're going to say is let y be equal to root x. Okay, and this is okay to do. So we're going to have y squared plus 4y minus 32 is equal to 0. Now this looks more like a quadratic when you look at it, right? You can definitely see that this is a quadratic now. So as you can see, we just convert it in a easier to see quadratic form. So if we factorize this, we'll have y plus 8 multiplied by y minus 4 is equal to 0. Again, if you can't see it, just take the longer steps, so at least you know you have the correct answer. And just to make sure, you can always expand this out and you should get back this. Okay, so therefore this would imply here now that y is equal to minus 8 and y is equal to 4. Okay, but remember, they didn't ask us to find for y. Okay, they've asked us to find for x. Okay, so therefore what we say is root x is equal to minus 8 and root x is equal to 4. Okay, this would therefore imply that x, if you square both sides, is equal to 64 and x here is equal to 16. Now, an important thing to do in questions like these is to insert your answer into the original equation and make sure it makes sense. Okay, so we should definitely do that. So if we plug in 64 into this, we get 64 plus 4 multiplied by square root of 64 minus 32. And if you actually do that in a calculator, it is not equal to 0. So therefore this here is not a solution. X is equal to 64 is not a solution. Okay, so this is the importance of just subbing back whatever you found x to be into the equation, so at least you know you have the right answer. And then we have x is equal to 16. If we substitute x is equal to 16 into this equation, we get the correct answer. Okay, so we therefore x is equal to 16 alone is our solution. Okay, so that was it for that question. Next one here now, we have, given that 9 to the power of p multiplied by 27 to the power of q is equal to 3 to the power of n, express n in terms of p and q. So what we notice here is that this here could be expressed in the form of 3 to the power of something, and this here could also be expressed as 3 to the power of something, because 3 cubed is 27. Okay, so to simplify it, now what we're going to do is let all of this b to the base 3. So this would actually be 3 squared to the power of p multiplied by 3 cubed to the power of q, which is equal to 3 to the power of n. Okay, now using the laws of indices, this is a power rule. Okay, therefore it will be 3 to the power of 2p multiplied by 3 to the power of 3q is equal to 3 to the power of n. Okay, therefore we'll have, using the multiplication rule, we'll have 3 to the power of 2p plus 3q is equal to 3 to the power of n. Okay, and now since the 3's here are equal, this would imply that n is equal to 2p plus 3q. Okay, and that was it for this question. Okay, once the bases here are the same, that would also mean that the powers would be equal to each other. Okay, next question here now. Evaluate 64 p to the 12 q to the 9 all to the power of 1/3. Okay, one of the best ways to do this now is that we could actually split this up. Okay, so what we're gonna do is, another way we could write this, since they all to the power of 1/3, this is the same as writing it as 64 to the power of 1/3 multiplied by p to the power of 12 to 1/3 multiplied by q to the power of 9 to the power of 1/3. Okay, and using the power rule, now we could actually simplify this. 64 to the power of 1/3, this is actually 4, so it would be 4 multiplied by, if we simplify this, remember this is the power rule, so therefore all we're doing is multiplying here, right? Okay, so it would be p to the power of 12 over 3, which is the same as p to the power of 4. Okay, right? And then we would also multiply this by q. Again, we multiply, so we multiply 9 by 1/3 and we'll get 3. So this is the equivalent of 4 p to the 4 q to the 3. And that, if we simplify that complex term, we would simplify down to this. Okay, so now we have another simplified question. Okay, so again, the best thing to do is to break up all the terms to the power of 3/4, because it'll be easiest that way. Okay, when they have questions like these. So this here now would be the same as 81 to the power of 3 over 4 multiplied by x to the 4 to the power of 3 over 4. Okay, divided by y to the power of 12 3 over 4. Okay, now what is 81? 81 is actually 2 to the power of 4. Okay, so I'm going to replace this 81 inside here by 2 to the power of 4. Okay, now using the power rule, we multiply the power inside the bracket with the power outside the bracket. So it becomes 2 to the power of 4 multiplied by 3/4, which is actually 2 to the power of 3 multiplied by x to the 4 x to the 4 multiplied by 3/4, which is equal to x to the 3. Okay, all over y. So if we multiply this now, it becomes y to the power of 9. Okay, and this is the same way now. So we have 2 to the power of x, sorry, to the power of 3 multiplied by x to the power of 3 all over. Now if you want to put this to the power of 3, we just simplify it. Okay, this would actually be y cube all to the power of 3. Okay, and therefore what this is equal to is 2x over y cubed all to the power of 3, and that is what it simplifies to. Okay, and that was really it for this topic of indices. This is really as hard as the questions come. They are relatively simple. So I hope you learned something from this video, and I hope you understand how the theory we learned in the previous video applies to this video. Okay, and thanks for watching, and I look forward to you watching the next video. Thanks.